Does temperature affect viscosity? What is viscosity? Viscosity is the measure of internal friction in a liquid or the resistance to flow in a liquid. For example, if you set a ship to motion, it would come to a halt because of the viscosity of the water, which resists the flow of the boat unless a propeller is attached. At low viscosities, fluids flow easily, such as water and alcohol. At high viscosities, fluids flow slowly, such as molasses.
What will we use to measure the effect of temperature on viscosity? Motor oil. Motor oils are differentiated based upon viscosities. They have a number on them, the SAE number, which tells you the viscosity. The first part of the code, i.e. 10W and 5W, is the apparent viscosity of the motor oil when it is cold, as the W stands for winter. The second part of the code, i.e. 30 and 40, is the apparent viscosity of the motor oil when it is hot.
How will we do our experiment? To test if temperature affects viscosity, we're going to use 4 different motor oils of different viscosity each. The first motor oil is a 10W40 motor oil. The second motor oil is a 5W30 motor oil. The third motor oil is a 10W30 motor oil. And the fourth motor oil is a 5W30 motor oil that has been used in a car and is now 6 months old. And we are going to test if a motor oil being used has any effect on the viscosity by comparing it to the other 5W30 motor oil, which is brand new.
We are going to fill these 2 graduated cylinders up with the motor oil, and then we're going to use these marbles and we're going to drop them in and see how long it takes to reach the bottom. The longer time it takes for the marbles to drop to the bottom, the higher resistance, and so it has a higher viscosity. The less time it takes for the marbles to drop to the bottom, the lower resistance, and so it has a lower viscosity. We are going to change the temperatures, and we're going to measure the temperatures by using this thermometer. We are going to have 7 different temperatures, and we're going to get the temperatures by using these jars to either heat them or freeze them.
In the video, we are going to show you 1 trial at the highest temperature, 1 trial at the medium temperature, and 1 trial at the lowest temperature. A little disclaimer is that the 5W30 used motor oil is black, so it is a little hard to see the marble in the video.
These are the medium temperature trials, which are at 21 degrees Celsius.
Let's see how a lower temperature affects the viscosity. The next trials are at 0 degrees Celsius.
At a lower temperature, the marbles fill slower, which means it had a higher viscosity. Let's see how a higher temperature affects the viscosity. The following trials are at 42 degrees Celsius.
At a higher temperature, the marbles fell faster, meaning the viscosity was lower. Now, for our conclusion. On the data table are the 4 different motor oils. On the left are the 7 different temperatures, from 0 degrees Celsius to 42 degrees Celsius. For each temperature, for each motor oil, we have 3 different trials, and we found the average of those 3 trials. As you can see, as the temperature decreases for all the motor oils, no matter what the the time it takes to reach the bottom increases. For example, let's look at 5W30. At 21 degrees Celsius, it takes 0.55 seconds to reach the bottom. At 0 degrees Celsius, the marble takes 1.51 seconds to reach the bottom. Since it took more time to reach the bottom, that means there was more resistance provided by the motor oil. So as the temperature decreased, the viscosity increased. Now, for 5W30 at 21 degrees Celsius, it was 0.55 seconds. But as the temperature increased to 42 degrees Celsius, the time decreased to 0.19 seconds, meaning the resistance provided by the motor oil decreased. So, as the temperature increases, the viscosity decreases because the resistance provided by the motor oil decreases.
On the graph, we plotted the average time of each motor oil at each temperature. As you can see, the 10W40 was the most viscous, and so it took up the most amount of time, no matter the temperature. And the 5W30 was the least viscous, as it took the least amount of time, no matter what temperature. The 5W30 motor oil and the used 5W30 motor oil did not show any significant amount of differences. The best fit lines were pretty similar, and so we can conclude that a 6-month-old used motor oil and a new motor oil does not show any significant differences in viscosity. So to conclude our experiment, temperature does affect viscosity. As the higher the temperature, the lower the viscosity, and the lower the temperature, the higher the viscosity.